Hi everyone, howdy. Welcome back for another cool geometry video. Today we are going to learn about a lot of things. Wow, and what's one of those things? Well, one of those things is a pattern I like to call tessellation. What now? Tessellation. Oh yeah! Tessellation is a pattern of closed figures that completely cover a surface with no gaps or overlaps. This beehive above is a tessellation of one figure, a hexagon, because 1, 2, 3, 4, 5, 6 sides are present in here. Oh, I get it! Yes! The beehive has hexagon shapes, and these hexagon shapes form many different kinds of tessellations. You remember how bees work, right? Bees just get the flowers to collect the nectar, and then they bring the nectar back to the honey. The hive in which they bring back the honey kind of looks like that, except with different tessellations. So, yeah, always hexagons for a honeybee hive. Yes. And trust me, you don't want to bother a honeybee hive, because you know what's going to happen. They're going to attack you, so... In this unit, we used squares as standard units of area. Any figure could be used as a standard unit of area, as long as the figure will cover a surface without gaps or overlaps. The area of this beehive could be measured in hexagons. So any figure could be used as a tessellation, as long as the figure will cover a surface with no gaps or overlaps, like hexagons. Can you show me an example of a tessellation? Actually, yes. I have seen a tessellation close to home. Tessellations. Wow. 1, 2, 3, 4, 5, 6. Hexagonal tessellations. Very cool. This is a tessellation close to home. This is one of the walls in our home. Wow, that's a very cool tessellation. Yes, tessellations could have amazing patterns. However, not all figures could tessellate. For example, a circle does not tessellate or cover a surface without gaps or overlaps because it is always round and will leave some form of gap or maybe even overlap over there. So circles, nope, they cannot tessellate. Remember that. Round shapes cannot tessellate. But shapes like squares and 1, 2, 3, 4, 5, 6, 7, 8, octagons. Like squares and octagons, they can tessellate. But circles cannot tessellate. But squares and octagons could tessellate. It just matters about the different kind of shape. Yes! That's it about tessellations. Wait, already? This lesson was quick. We're not done yet. Remember when we said we're not going to talk about the heptagon? Yeah? Well, I actually changed my mind and discovered that the heptagon will be good enough to talk about. So why not? Let's dive in. What is a heptagon? Oh, I remember. A heptagon is a shape with 7 sides. That's right. Wait a minute. That does not look like a heptagon, but it is a heptagon. See? 1, 2, 3, 4, 5, 6, 7. 7 sides. Yeah, but it does not look familiar. This is because it is an irregular heptagon. What's an irregular polygon? An irregular polygon has sides that are of different lengths and angles that are of different measures. So, it is the opposite of a regular polygon, which has all sides and angles equal. An irregular polygon, like this heptagon, does not have all sides the same length, and all of the angles are of different measures too. So, no matter how big or small, or which way up the shapes are formed, it is still a heptagon. All that matters is how many straight sides. And so that the sides do not intersect. Because if the sides intersect, then it is not a polygon. Yes, so Yeah, very cool. Wow. Interesting. Yeah. You could find the area of an irregular heptagon, but we're not going to talk about how to find the area of irregular polygons, because that's too complicated. But I will show you the actual formula of how to find the area of a regular heptagon. This formula only works for heptagons that are regular, not irregular. The formula is this. The area of a regular heptagon only is 7/4 a squared times cot times 180 degrees divided by 7. Wow, wow, wowzy. A lot of things over here, but we are not going to use that formula because we are not even going to dive into the area of heptagons because we already know how to find the area of any polygon thanks to our isosceles triangle method. Anyway, there is also this other shape. There is a 9-sided shape too, called a nonagon. N-O-N-A-G-O-N. Nonagon. Ooh. This is a nonagon, right? Correct! Because no matter which way the sides are arranged, it's still a nonagon. All that matters is 1, 2, 3, 4, 5, 6, 7, 8, 9. Straight sides. Let me just count again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes! 9 straight sides. That's a nonagon. The area of a nonagon that is only regular, not irregular, has this formula. The area of a regular nonagon and not an irregular one is 9/4 times a squared times cot times 180 degrees divided by 9. That's for a regular nonagon, not an irregular nonagon. So, yeah, that's the area formula for a nonagon, but we're not going to use that. And finally, there is this one final shape, which has 10 sides. There's a 10-sided shape? Wow. We just keep discovering new and new shapes. These shapes were already discovered. Oh. But they are willing to await for us to make a new discovery. Wow. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow. A decagon can be a step shape. A decagon, is that what it's called? Yes. A 10-sided polygon is called a decagon. D-E-C-A-G-O-N. Ooh, and by the way, heptagon is spelled H-E-P-T-A-G-O-N. A decagon has 10 sides and 10 corners. Very interesting. What is the formula for finding the area of a regular decagon? Well, it is complicated as well. Never would have guessed. The actual formula for finding the area of a regular decagon, not an irregular decagon, is this formula. To find the area of a regular decagon, not an irregular decagon, you have to do 5/2 times a squared times the square root of 5 plus 2 times the square root of 5. Never knew square roots could be inside a square root. Very, very interesting. Yeah. Okay, that is the area of a decagon, but we're not going to use that one because we are not even going to mention the areas of such shapes. So, that's all we have here. Heptagons, nonagons, and decagons. Oops, too bright. Heptagon, nonagon, decagon. No matter which way up, how big or small, no matter if it's regular or irregular, it is still a polygon, because all that matters is how many straight sides. That's right. Woo-hoo-hoo! We learned so much today. Yes, we did. There is also this thing that you could possibly find the area of a tessellation, but we are not going to find the area of a tessellation because I think that's too difficult. So, this is where we stop. That's it for us today. I hope you enjoyed this video about all different kinds of polygons and how they could be regular or irregular. And about tessellations, too. Tessellations are pretty great, I could tell you that. It's like a pattern. Bye, everyone! Bye! We'll see you in the next video. Bye-bye, guys! Bye! My brother!